Hey guys, welcome to Inequalities, our new unit, Unit 4, Day 1. Let's get started. Alright, I'm going to graph x is less than or equal, less than 3. This means less than 3. And somehow I've got to represent on the number line all the possible values on this number line that make this inequality true. So who's chosen? Let's see, -2 works, -1 works, 0 works, 2 works, but 2.5. 2.5 works. Does 3 work? No, I gotta stop at 3. Anything that's 3 or above doesn't work. So let's see. The way I represent this is I place a circle on 3. Now I've got to figure out which side of the inequality am I going to graph. All the values that are less than 3. Now 3 is the larger side of the inequality. You can see that this symbol opens up to 3. Some of you learned it that way. So 3 is going to be larger. It's going to be to the right of all the possible values of x. So I'm going to represent that by drawing actually a ray coming from that point. But it's an open circle because 3 is not a value that's included. Okay. So this shows me everything on the number line up to but not including 3. Okay. Now let's look at this next inequality. It's x is less than or equal to 0. So now I'm actually including this boundary of 0. So I'm looking for all the values that are less than 0 or equal to 0. So since 0 is included, the way we show this, the way we show this is we draw that circle and we put it on 0, but to show that equality is there, to show that 0 is actually a possible solution to this inequality, we fill it in. And that's not how we do it. We fill it in. So now 0 is a possible solution, and so are all the other numbers to the left of 0. -1 would work. So would -3.5. But 1 doesn't work. 1 is not less than or equal to 0. Okay. X is greater than -1. X is the larger value, and -1 is a smaller value. So I put my circle on -1. Now I got to figure out whether I'm going to graph the right side or the left side. So I'm looking for all the possible x values that are larger than -1. So I'm going to be graphing everything to the right. Okay. X is greater than or equal to -2. Okay, so I'm going to draw my circle on -2. Let me see. Is -2, was -2 a solution to this inequality? Yeah. I could put -2 in here. -2 is greater than or equal to -2 because -2 is equal to -2. So I'm going to fill that in. Not that way. When am I going to learn? -2 works. And I'm looking for all the values that are larger than -2. And there we go. Okay. -2 is on the smaller boundary. You can see because it's being pointed to. -3 is less than or equal to x. It's okay for the variable to be on the right. It doesn't matter what side the variable's on. But you can tell that this variable is on the higher boundary of my half line. You can see that it's kind of opening up to x. And -3 is on the lower boundary of this. So I draw my circle on -3. all the possible values of x that would make this true are to the right of negative 3. I can check. Pick any value and check. Let's see, 0. Is negative 3 less than or equal to 0? Yeah, it is. So it works. I'll graph the right side of negative 3. Okay, now 0 is greater than x. That means that x is less than 0, doesn't it? So I'm going to put, oh, you guys, you allowed me to forget this part. Negative 3 is included. Negative 3 is less than or equal to negative 3. I've got to include this. The way that I show that it's included is I shade it in. Okay. This is a closed circle because negative 3 is a solution to this inequality. But here, 0 is not a solution. Okay, 0 is not greater than 0. So I'm not going to include 0. But am I going to include 1, 2, 3, and 4? No, 0 is not bigger than those. But I am going to include negative 1, negative 2, negative 3, negative 4, and all the numbers in between. And there you go. X is equal to negative 1. You know how to graph that. But just to refresh your memory, negative 1. And how do I show that negative 1 is included? It's actually the only point that's on the number line that's included. I'm going to fill him in. I can make him a closed circle. You knew I was going to do that, didn't you? Okay. Now, x is not equal to negative 2. So that means actually every single number on this entire number line is not equal to negative 2 except for one point. Which point is it? Yeah, negative 2. So it means that somehow I got to show that everything's included except for negative 2. And I do that by putting an open circle on negative 2 and drawing lines to cover the rest of it. Alright, now let's talk about words. I need to graph the solution to a number less than 3. I'm looking for all the numbers that could possibly make this true. So negative 1 would work, 0 would work, 1 would work, 1.5 would work, 2.9 would work. I'm going to go actually all the way up to 3. I'm not going to include 3 because 3 is not less than 3. I can write this inequality as x is less than 3. But I'm not including 3. So I'm going to make that an open circle. Choose all the values that are less than 3. There you go. These are all the numbers that are less than 3. Now I'm looking for a whole number that's less than 3. So now I actually have some restrictions here. I can't include a half anymore. And I can't include negative 1. I can only include 1. Actually, I include 0. 0 is a whole number. 0 I can include 1. I can include 2, and I cannot include 3. So, let me represent that. I'll do that myself. Include 0. Include 1. I'm going to include 2. But I'm not going to include 3. Okay. Looks like I'm done. I've shown all the possible whole numbers that are less than 3. Okay. If I'm renting an apartment and my lease says I can have no more than 3 pets, what they're really telling me is, you see the word more, and more doesn't really mean greater here. It's no more than. So it's really, I can have less than or equal to 3. Now, x has to be a whole number because there's no such thing as -1 pets or half a pet. So I designate that here. I say x is less than or equal to 3 because it can be 3, but I'm also saying that it has to be a whole number. So 0 works, 1 works, 2, that's closed, 2 works, and does 3 work? Yeah. If it says I can have no more than 3, I can have 3. And 3 works. There you go. Okay. Say a Girl Scout troop must have at least 5 members. So I see least, and in my head I think less than, but that's not the case. We need to remember the vocabulary in the section. So if I'm talking about at least 5 members, that tells me that, can I have 5? Yeah, I can have 5. I can have 5. Can I have 6? Can I have 7? Yeah, these are all valid amounts. Can I have 8.5? No, just talking about whole numbers here. Whoops. Well, you know it's up there. And wow, that's some really major stuff there. Let's get rid of all that. Now the inequality, if I were to write that, is x is greater than or equal to 5. And I would say that x is a whole number. So at least means greater than or equal to. At least means greater than or equal to. Okay. If I tell you you must read for at least 1 hour. Let's see. So 0, no, it's not going to work. Half an hour, don't try it. An hour, yeah, that's good. That'll work. How about an hour, 1.1 hours? Yeah, that'll work. How about 2? That'll work. So I'm going to draw that. Draw that line, that ray coming from 1. But I'm including 1. So if I write the expression, I've got, or the inequality, excuse me, I have x is greater than or equal to 1. That's what at least means. At least means greater than or equal to. If I tell you x is at most 1, that means I can have any number for x up into and including 1. Since I'm including 1, I'm going to color that in. I'm actually going to try to draw the line like this. Okay, very good. And if I were to write this this inequality, it would be x. No, it wouldn't. It would be x is less than or equal to 1. At most means less than or equal to. For me, it's easier to draw the graph and see, and then write the inequality. You might like to do it the other way around. Your job now is to graph these inequalities. So go ahead and pause me, and unpause me when you're finished. Here I want you to translate from English into a mathematical inequality and graph it, please. For 12 through 14, change your graph, change your number line rather, so that the numbers make sense according to the problem. So in number 12, I want you to graph for me all the ages of students that are too young, that are not able to be admitted to rated R movies. I want you to graph appropriate temperatures for you to come to school and not get us all sick. And I want you to graph all the grades, all the possible passing grades in my class. And I'll see you at school.